All right, working back with similar figures again. Looking at this, first off, we want to write our triangle similarity statement. So we're going to say triangle ACB. So we're going to work from the right angle to the far corner up to the top. We're going to do the same thing with X, Z, Y. We're going to try and call that our triangle similarity. Triangle similarity statement. Okay, so now we want to write an actual similarity statement. So what side over what side? So if we talk about A to B, so we're going to put AB on top. And if we talk A to B, we're going to talk, and we look at AB, and we're going to similar to XY. So we got AB, XY. Now we're going to go AC, because we have to stay on the same triangle. So we're staying with this big triangle, keep it on top, keep it consistent, and we're going to do XZ. And that is going to be our similarity statement. Okay, so we've got our triangle similarities. Now we have our side similarity statement. So now what we can go ahead and do is substitution. We're going to substitute our values into this. So when we look at this, we want AB first, which is going to be 8. Oops. Let's try that again. H over XY, which is going to be 6, equals AC, which is 60, over XZ, which is 15. And that's going to be substitution. So all we did was substitute our values in for what our segments were. So we talk about all these different segments. We're just substituting what the values are for those segments. So we have H for this one, 6 for that one, 60 for this one, 15 for that one. Now, ever famous, we are going to cross multiply. So when we do this, we're going to multiply 15 times H and then 6 times 60. And we call that cross multiplication. So cross multiply is how we shorten it up. Now, once we do that,
Are you live right now?
Yeah,
oh,
but
what?
Okay. All right. So we have 15H. Oh, it didn't change, or it's not much of a color change. Let's go up here. Let's try this. All right. 15H equals, and then we're going to do 6 times 60. I didn't open my decimals. All right, well, let's do this. 6 times 60, and we get 360. So that means we're going to put 360 here. So 15H equals 360. We'll just call that simplify. You can put multiply if you want to be more specific, but at the end of the day, we just need to justify what we did, and we just combine these like terms. We want to do 6 times 60 to just get one value. So once we do that, now we want to get H by itself. So we have to get rid of the number next to H. So we're going to divide both sides by 15. So now let's take that 360 we got and divide it by 15, and that's going to give us our solution of 24. And we got that by division property of equality. Okay, so that gets us our solution, and there's our justification for it, and we are good to go with this problem. So go ahead, try this problem. I'm actually going to leave this one alone for my students, but same setup. If here, let's just do this. So we talk about triangle similar to triangle. I'll give you the triangle similarity statement. Okay, so when we look at this, once again, start at that right angle. The right angle is sometimes the easiest one to follow, and we're going to come away and go up to the top. So we do that, we're going to do C to A to B. Let's spell a cab. Okay, so C to A to B. So if we do the same right angle idea, we're going to go Z to x to y. Okay, so there's our triangle similarity statement, and then I want you to take off and go running with that problem. All right, now we did quite a few of these in class today, but more practice makes perfection. So we're going to continue on, but my students should know that I told them we're going to start in the center dot right there, that G, and we're going to go towards the right angle and then up. And then we're going to go towards the right angle and down. So when we write this similarity statement, we are going to have triangle GFE. FE is similar to triangle GHI. GHI. And we call that triangle similarity. So we're just writing which triangle is similar to which triangle. And doing this, you kind of can say you can stay consistent with the letters. So if I know if I use a G right here, I got to use a G here. If I use, let's call an F, I need to use an H. And then if I use, let's use yellow. If I use an E, I got to use an I. So knowing that you're consistent with your letters, that's why we really write the triangle similarity statement. So we're going to go G to F. And if we go G to F, we have to go G to H. And if you look, the first two letters, GF, first two letters, GH. So that helps you to double check your work to stay consistent. And then we're going to go FE. And the reason we're doing FE is because remember, we started G to F. So we started this big triangle, the upper triangle, first. So we want to make sure and stay with the upper triangle second when we do the next similarity. Or proportion, I should say, because we're writing a fraction. So then this one, we want to do HI. And we can call this our similarity statement. Now we're going to do substitution. So we want to plug some values in for this. So when we do this, we want to know what GF is. And it says that it's 78. And then GH is going to be 45. FE is going to be our unknown. We're going to label D. And then HI is 180. And all we did was we just substitute our numbers in for our segments. So now we can do our famous cross multiply. Okay, and we're going to start with 45. Oops, that's not a 5. Let's try that again. 45 times D. I always like to put the variable on the left. It doesn't matter. As long as you do it correctly, you will get the same answer either way. But me, I just like keeping the variable on the left-hand side. And then we're going to do 78 times 180. And we call this cross multiply or cross multiplication. So now we're going to stick with 45D. Let's not do anything with that yet. We want to do 78 times 180. So really, we want to do 78 times 180 and, oops. Okay, great. 78 times 180 and get 14040. 14040. So 14040. 14,040. We can just put simplify here or multiply, combine like terms, whatever one fits you best is the one I want you to use. And then the last step, we need to get D by itself. Our goal is to figure out what D actually is. What's this length, okay? So when we do that, we need to get rid of the number next to D. So we're going to divide because in between 45 and D is multiplication. And the inverse operation or the opposite of multiply is divide. So we're going to divide both sides by 45. So once we do that, let's go back to that Desmos. We can hit divide. We're going to do 14040 and we're going to divide it by 45. And we're going to get 312. And we did that by division property of equality again. But let's be even more specific. Now we found the distance. So we found the distance D equal to 312 meters. And that is our missing distance that we hit. Okay? With story problems, you should write some kind of statement saying what your answers are. Some teachers really care about it. Other teachers, not as much. But I would tell them, if you were to write each of these statements with justification, I'm sure your teacher may overlook the fact that you didn't write distance equals 312 meters. You're giving a lot of information here. You're showing that teacher that you know exactly what's going on with the problems. Okay? So, another one I'm going to have my students try. I'm not going to do this one, but just to take a look, if you want to pause the video, I'm not even going to give a triangle similarity statement this time. I want my students to practice a little bit. There's plenty of problems to do. I helped with 1 and 3. I'm going to do 5 and 6. I want them to be able to do 2 and 4 on their own. So let's talk about this one. Jenny, and story problems are very arbitrary. They're written almost the same all the time. They're going to give you some story. They're going to put some numbers in. And then the last question or the last sentence in each of these story problems is probably going to be where the question is. Most times. Now, part of this, our problem is, Jenny is 5 feet 2 inches tall. To find the height h of a light pole, she's measured her shadow and the pole shadow. What is the height of the pole? So once again, we're looking for this, which is fine. But here is our real issue with this problem. 5 feet 2 inches is not an answer. It's like saying 4:30. And 4:30 is not 4 hours. I guess if you want to look at this as 4 hours and 30 minutes in a decimal stance, you're really looking at 4.5 hours because 30 minutes is half an hour. And how do we get that though? What's the conversion? How did we just say it's 4.5? That doesn't make sense. Well, think about it in this case. If we have 4 full hours, that's great. But we also have 30 minutes. But how many minutes make up an hour? Isn't it 60? So when we convert that, that's going to be a half an hour. And if we know our fractions, or at least a little bit of our fractions, $0.50 is 50 cents, right? So that's where the 0.5 comes into play. And if you don't believe me, we could do 1 divided by 2. 1 divided by 2 and get 0.5. We could do 30 divided by 60 if you just want to go straight from the minutes. So you can start to see how that conversion factor works. Well, we're not dealing with time in this one. We're dealing with inches. And I put a hint here to convert Jenny's into decimals. So there is 12 inches in 1 foot. So we have, oops. Man, I don't know why it keeps doing it. We have 5 feet and 2 inches. So if we wanted to take that 4 hours and 30 minutes, we really want to take that 5 is going to be a full 5, but we're going to take the 12 or take the 2 and divide it by 12 because that's our conversion factor. There are 12 inches in 1 foot. So to make this a decimal, we're going to do 2 over 12. And if you know fractions, we can divide the top and bottom by 2, and that's going to give us 1/6, which is great. But really, we're looking for 1 divided by 6, which is 0.1, and I'm going to say 0.17. So I'm going to do 0.17. So this is going to be 5.17 as my height of Jenny. Same thing. We have 7 feet. That's not a double F. FT. 7 feet. And we have 9 inches this time. Well, that 7 feet is fine. The 9 has to be put over 12. And if we do this, it should be 3/4. And if you know your fractions better than me, because I didn't know 1/6, I think I could have calculated, but It's quicker just tap it in. But 3/4, 3/4 is 75 cents. So this is going to be 7.75. So we've converted this and we converted that into an actual decimal. That's going to be the trickiest part of this problem because it gave us 15.5 feet. So that feet, inches, we had to kind of play that game so that they're all the same units. And these are all in feet now. That is the toughest part. So now we can do Jenny over light, GHT, okay. And then we can do Jenny's shadow over light shadow, which I know sort of doesn't make, but it's the light pole. I'm just calling it light. And then this is going to be our similarity statement. Okay, so before, when we did the segments, they don't have we don't have A, B, C, D, E, F, none of that. So what we're going to do is actually write out what we are trying to measure. And Jenny, we know is, so when we do our substitution method, we're going to put 5.17 for Jenny. The light is what we're looking for. That's going to be H. Jenny's shadow, we're going to put that 7.75 now that we found, and then the 15.5 that was given. And we're going to call this substitution. And, you know, you could have left this kind of in your 2-column proof to show the conversion factor. I think the side work is okay for me, but if you really wanted to make this a college formal proof, you would probably want to put that in your proof as well somewhere. Otherwise, you might just be making these numbers up, which we're not. We did a great job. All right, so now we're going to do our cross multiplication. So you could write cross multiply, or we can write it out and then write it 0.75. And I do this big dot kind of to not get it confused with a decimal. So that's why when I do these multiplications, you saw on this one, I made a big dot. On this one, I made a big dot because sometimes when you see decimals and then you see this, I don't want this to get confused or think you have to do 7 times 75 times 8. Like, that's where it gets kind of tough. So I try and make my decimal small, but my multiplication dot really big. And we're going to put cross multiply here. And we're going to do that. So 5.17 times 15.5. 5.17 times 15.5. 80.135. Good gracious. All right. Well, that's just 80.13. 80.135. And we're going to have 7.75H. You're working with decimals. In scientific notation, you'd be counting them out. You'll probably be doing 1 decimal place because this is the one, only has 1 decimal. But that's a little more deep than what math usually does. We're going to just keep our decimals. Eventually, hopefully, we just round it out to 2 when we're all said and done. So once again, we want to get H by itself. Ooh, sorry. We want to put simplify here. So we want to get H by itself, so we need to get rid of the 7.75. Hopefully you're seeing the pattern that consistently happens in math when you do problems, is you typically start to repeat the same process over and over and over again. So we want to get rid of the number next to H, and we know there's multiplication in between here, so we're going to do division to get rid of it. And when we do 80.135 and divide it, 80.135 and divide it by 7.75, we're going to get 10.34. So it did kind of round itself out. So 10.34. And that's the division property of equality. And then because it's a story problem, we can now say the light pole is 10.34 feet tall. So just under 11 feet, just above 10 feet tall. So standard light, sounds about right. Okay. And then lastly, we want to find the height of this dinosaur in a museum, and it's a Tyrannosaurus Rex. Amir placed a mirror on the ground 40 feet from its base. So we know this mirror is 40 feet away from our T-Rex. And he stepped back 4 feet. So you can see we are 4 feet away. So you're starting to see they're setting up similar triangles again. 5 feet 6 inches. Well, unfortunately, that means we got to do a little conversion. 5 feet 6 inches is going to be 5 and 6 over 12, which is going to be 1/2, which hopefully you're going to say is 5.5. So we're going to cross this out, and we're going to put 5.5 feet to make sure that we are standard in our units throughout the entire problem. We don't want to mix and match. That will really get us. So we have Amir. And then we have the dino. And then we have the Amir's distance from mirror. So how far away Amir is from the mirror. And then we have the dino distance from mirror. And it's a little bit to write, but you really want your person that's looking at this to know why you're substituting the values in that you are. So this is our similarity statement, and it really shows the teacher that you do know what you're talking about when you're making these similarity statements. You know that we're looking at this as our point, and we're going back to the 90-degree angles, then we go straight up. And that gives us our 2 similar triangles that we are setting up. So now the Amir's height we know is 5.5. The dino's is what we're looking for. And then the distance from the mirror is 4 feet. And then the distance to the T-Rex is 40. And that's going to be substitution. And I am going to stop there and hope my students can finish the rest of that. Okay? So these are our story problems involving similar triangles, but it's hopefully a lot of the material that we've already been looking at and doing on our process from last week, and we're just kind of adding on just a little wrinkle or a little extra. The biggest thing, make sure your units are all the same. So if they do feet and inches, you need to convert one to the other and vice versa. And hopefully, if you don't know the unit conversion, ask your teacher a question, because sometimes that's an equity issue. It really, everybody should know, but sometimes you have to go on faith that some students might not know how many quarts are in a gallon. So having just that question of asking the teacher saying, should I really know this, or can you help me out? Don't be afraid to do that. But yeah, make sure all your units are the same, and then work forward for your triangle similarity statement, then your regular similarity statement. And if you don't have letters on it, start to really break it down and say, this is what I'm talking about. So I'm talking about Amir's height, then I'm talking about the dino's height, then Amir's distance to the mirror, and then the dino distance to the mirror. So you're really labeling as much as you humanly possibly can to let that person know you know how similar figures work. And then substitute, cross multiply, and then simplify and solve. I really appreciate everybody that stopped out. And remember, if you ever need any help, please, there's a link in my TikTok, but please feel free to join my Discord channel. If you want to ask questions in here, I will be happy to answer them. But just want to give people a space to feel comfortable asking for math help. The side business hasn't really been much of a business, so I'm just really here to help people learn math. So anything you ever need, just click, send me a message, and in Discord it definitely is helpful because you can clip and paste. I think the last one I just did was like doing triangle proofs. I didn't do this. This one was crazy. That one I had to pass off to his teacher. But yeah, just come on in. I can answer some questions. I even made a TikTok over the first question and linked and, messaged that person and let them know that their answer was there. So really just want to be helpful. So have a wonderful night. And for my students, keep working.